In this lesson, we are going to graph polynomial functions based off of their different characteristics that we previously talked about. First, we will expand the polynomial function if needed. Then we will determine the end behavior of the graph. We will find X and Y-intercepts. We will determine the real zeros and their multiplicity so that we know whether the graph touches or crosses the x-axis at those spots. We will also determine the max number of turning points and then use the information to help us create some intervals to find some additional points. So the first thing we have here, we're going to graph this polynomial. We can go ahead and expand it. We'll just expand this one. We won't expand our other ones. And if we do that, we get 2x plus 1 times x squared minus 6x plus 9. That would be 2x cubed minus 12x plus 18x. Plus x squared minus 6x plus 9. And that is 2x cubed plus let's see, 2x cubed minus 12x squared, 12x squared plus 18x plus x squared minus, all right, there we go. So 2x cubed, that's going to be minus 11x squared plus 12x plus 9. So there is our polynomial expanded. So our end behavior is going to behave, so our end behavior resembles the power function, which is 2x cubed. So that means it's going to look like that. So we can kind of sketch that on our graph here if we want to. We don't really know where it's going to go through yet, but just kind of plot that on there. Finding the X and Y-intercepts. I'm going to add step 4 to this because we're asked to find the zeros. Well, the X-intercepts and the zeros are the same, so I'm going to do this together here. So if we set 2x plus 1 equal to 0, we would get negative 1/2. And if we set x minus 3 equal to 0, we would get 3. The 3 has a multiplicity of 2. Negative 1 has a multiplicity of 1. That tells us that it's going to cross the x-axis at negative 1/2, and it's going to touch the x-axis at 3. So if we go ahead and plot those, negative 1/2 is going to cross there. So I'm just going to kind of put a line through there. And at 3, it's going to touch and turn back. So I have that in mind. Our max number of turning points is our degree minus 1. Our degree is 3. So we're going to have a max of 2 turning points. So we kind of have a general idea here. We haven't found our y-intercept yet. So the y-intercept, that's when we evaluate the function at 0, which is 9. So go ahead and plot that. 0, 9 is our y-intercept. So you can kind of already see how the graph's going to look. Now, my end behavior arrow didn't lie right, but I know it comes from the bottom. It goes up, and it's coming down, turning, and then ends up going back up. Okay, so my graph looks something like that. If we're graphing by hand, then we're going to want to find some intervals with some more points here. So if I just do negative infinity up to my negative 1/2, my negative 1/2 to my other 0, 3, and then 3 to infinity. I'm going to test a point in each of those intervals so that I know where some other points are. So if I find f of, let's do -1. So f of -1 would be -16. So that means the point -1, -16 is on the graph. So everywhere in that interval is going to be below the x-axis. Same thing if I test f of, let's do 1. Then we would get 12. So the point 1, 12 is on the graph, and that whole interval would be above the x-axis. And then if I test 4, I get 9, so 4, 9 is on the graph, and that whole point is above, or that whole interval is above the x-axis. Okay, so you could add those points. So -1, 16, we can't really add. 1, 12, we could kind of add. So actually, we should have done this. And then 4, 9. Because really our turning point is all the way up here. So our graph should have been like that. Okay, so it should be more of the purple line, not the blue line. If we were graphing it by hand, that is what you would want to do to make sure you get an accurate graph there. Okay, for this next one, we are going to kind of find the different characteristics and properties, but we won't actually graph it by hand. You'll see we would need a different scale, and on your homework, you'll be selecting the correct graph that matches. So as long as you have the general idea of what is going on, you'll be all right. So graphing the polynomial f of x equals x minus 2 times coordinate x plus 3 squared times x minus 5. We're not going to expand this one. We can tell, though, that the end behavior resembles the power function, and if I were to expand this, if I was thinking about how I would be squaring this x, and then I'd be multiplying by x again, so that's x cubed, and then I'd be multiplying by x again, which is x to the 4th. So this end behavior resembles x to the 4th. Y equals x to the 4th. And that's where they're both going up. So our end behavior both approach infinity. Our x-intercepts and zeros. If we set each of those factors equal to 0, we would get 2, -3, and 5. Our -3 has a multiplicity of 2. So we would cross the x-axis at 2, we would touch the x-axis at -3, and we would cross the x-axis at 5. Our y-intercept we find by evaluating the function at 0. That's 0 minus 2 times 0 plus 3 quantity squared times 0 minus 5. Which you end up getting to be 90. So there you can see we would have to change our scale on the graph that's there for us. And then the intervals that we could look at then would be -infinity up to -3, -3 up to 2, 2 to 5, and then 5 to infinity. So those are the different intervals we would test to see if we're above or below the x-axis. So just quickly here, if I found f of -5, I would get 280. Oh, excuse me. So that entire interval would be above the x-axis, and the point -5, 280 would be on the graph. If I tested the point -1, that is equal to 72. So that entire interval is above the x-axis. From 2 to 5, if I found f of 3, that is equal to -72. So that entire interval is below the x-axis. And if I found f of 6, that's 324. So that entire interval is above the x-axis. So you could use that to help you, let's see, I'll kind of sketch it out here, but we'll pretend that I guess these go by tens. So we would have 2, -3, and 5 as my zeros. My y-intercept is 0, 90. We won't plot the other points, we'll just talk about where they're above and below. So here I'm coming down and I'm turning because that was a multiplicity of 2, so an even multiplicity. We would come up to the intercept. It actually ends up going below the x-axis between 2 and 5. So it dips down here. This is where we would want to find an extra point for sure. And then it goes up. Okay, that's not the perfect graph because my scale is off, but that's just the general idea of what it would look like where it's below the x-axis on the interval from 2 to 5. And last one here, we're going to analyze the graph using a graphing utility. You can use your TI-84, 83. I'm just going to use Desmos. It's easiest for me to show you that way with my iPad here. So you would just type that function in, and when you do that, this is what you get. If you're doing it on your TI-84, you'd probably need to change your window a little bit so that you could see the whole thing. The end behavior is going to resemble the power function of x cubed. So resembles y equals x cubed, and we know that that's like that. Approximate the x and the y-intercepts. Well, on Desmos, we got an x-intercept there at -3.790. Our y-intercept is at 0, 2.484. Yeah. Okay. Let's see, I'll go ahead and write that down. Your y-intercept is also your constant, so that's the 2.484406. We wrote the whole thing. Our one x-intercept was -3.79, I believe. Yes. Approximate the turning point. So the turning points would be your max and your min. So if you were doing this in your calculator, you could do second trace maximum. You'd have to do your left bound, right bound guess. Same thing for the minimum, second trace minimum, left bound, right bound guess. So -2.28 and 13.35. Would be one turning point. Our other one is at 0.631. Yep. Let's see. Next, use the table to find points on the graph around the x-intercept. So in your TI-84, you would do second graph and it pulls up a table. And so we would want to find where, let's see, around the x-intercept, so we would find where x is -4 and where x is -2 and get your y values. You could, if you weren't using the calculator, just plug into the function and evaluate it there, but your table will just show you right away. And I'll just tell you for those, you get about -4. We'll go 5 approximately, and then -2 would give you about 13.0. Your domain and range would be -infinity, +infinity for the domain. Our range is the same since it's an odd function here. And then the intervals on which it is increasing and decreasing. Well, if you follow the graph, it's increasing from negative infinity up to the negative 2.28. It's decreasing from the negative 2.28 to the 0.63, and it's increasing again from the 0.63 to infinity. Oops. And there we have it from graphing on a graphing utility.